Good morning everyone, so welcome to TechDays Live at Future Decoded. So I'm Lee Stott, I'm the CTO of Academic Engagement for Microsoft UK.
I'm Tom Mulvaney, I'm a recent graduate of the Software Systems Engineering MSc program at UCL. I was the team leader for Spot Markets over the summer, which is a project we were doing with Microsoft and Kent County Council.
Excellent, Tom. So great to have you this morning. So we're going to talk a bit about how Microsoft and UCL have been working together to do projects for industrialization for student modules. So this is actually part of your degree, isn't it?
Yes, it was.
So in terms of the actual opportunity, what we've been doing is working very closely with you and your fellow team members in building out a great project. So let's just go through a quick introduction of what the purpose is. So the key goals for UCL is to try and create a real life situation for students to build a real proof of concept project. So you generally have 8 to 12 weeks depending on the course you're in. You start from an undergraduate level doing your BSc or BEng and then work up to a master's, either an MSc or an MEng. And as Microsoft, what we've been really trying to do is find great challenging projects which have a huge diversity of skill sets and technologies, mainly around Azure. So you've done a lot of things on Azure, which again we'll talk about in a bit, but it's really about giving you advice and guidance. So we're the custodians of the technology and you guys are the implementers, the creators, and sometimes we get some amazing patterns and practices and some great proof of concepts which clients then actually take in to real life scenarios. So in terms of your project was Kent County Council, wasn't it? So what were their sort of goals for the project?
Right, so the long-term business goals which future Spot Markets projects are going to continue to iterate on, it's about revitalizing the high street by connecting consumers with local small brick and mortar retailers.
So it's sort of competing with the Amazons and the eBays of this world. Okay.
It's for retailers who don't necessarily have the capital to invest in a large online infrastructure, and it's about helping out the little guy and allowing them to compete in a global marketplace.
Okay, so the local bookshops, bakeries, etc., and then bringing in that whole aspect of tourism and attracting the consumer on the high street to visit their local stores. Excellent. So, in terms of the short-term goals, we tried to develop the project brief because your project was over about 8 weeks in terms of the overall opportunity. And we broke that down into key milestones. So we had things like proof of concept. We wanted you to focus on specific technologies like the consumer app, machine learning. And then we had business KPIs and technical KPIs to really help guide you. And then as Microsoft, we're providing very much the technical advice in terms of, Machine Learning Studio, Jupyter Notebooks, Xamarin, and Kent County Council was providing the input from both the tourism perspective and the local reseller opportunity and engaging with local resellers to talk about how they could sell their goods in that digital high street. So if you just look at some of these, is this the sort of things you were doing already on your course, or was some of this completely new?
I had done a bit of machine learning over the course of the year, but we really went full on into machine learning and actually dedicated one of our engineers to that because it was such a critical part of the project. So it was a continuation in some respects of what we had already been doing, but there were a lot of
But it was that real
things.
grounding of technologies. And I love the way you said one of our engineers. So these are students, but they were a team. So you were the project manager, you were running VSTS, and you were Visual Studio. So you had source control, you had all the repos, you were doing continuous deployment, continuous integration, you had DevOps in place, and you had team members as engineers, software developers, PMs, etc.
Exactly.
So one of the great things we find about these projects is the whole learning outcome. So we've sort of built this model in terms of where we see the whole model sustaining itself. So we have experts from our technical evangelist team in the UK and in Redmond as well, where we provide experts advice in terms of that technology. We then have people within Microsoft, such as Microsoft Consultancy Services, or our new interns and graduate hires who need to get up to speed on this technology. And then we have the sponsors, so this could be the Microsoft Consulting Services, or an independent software vendor, who are the custodians of the business KPIs. And then we bring in mentors also from that organisation to help you. So we had some tourist people, and we had some of the local resellers, and then we've got you as a student. And we see this as like a learning curve going down. But then most importantly, from your perspective, you providing information back up to us at all the different levels. So again, you might develop a pattern or a practice around a certain technology, which then enables us to have extra learning. So we see this as a continuous learning cycle for everyone involved. And again, it's great from a university perspective because it gives citation and references. And for you guys, it gets you jobs. And it gets you real life examples and scenarios. So, when we actually sat down and look at the project, what are the key goals for you? We have this formal and informal meeting structure. So just tell me a little bit about what you think about these and how these are implemented.
Right. Well, it was actually very well conducted because we had a lot of support from multiple people at Microsoft. So we defined like an agile methodology. We used extreme programming, where we would conduct iterations and then have catch-ups with the clients at the end of each iteration. On top of that, we'd always have the weekly catch-up, which was important, even mid-iteration, for just keeping sure everyone's on the same page, making sure you don't leave it too long. Now, what was actually arguably as important as that was the informal talks that we were able to have. Getting that support from the technical evangelists and being able to arrange meetings with MVPs and everything was the chance for not just us to show the clients what we've done, but for us to get support where we've needed it, where we've had skills gaps.
Yeah, so we had like guest lectures arranged from both Microsoft and our Microsoft Value Partner community.
Yeah.
So we had like people like Gary Whittaker come in to talk to you about Xamarin, that whole...
And Bluetooth beacons.
And Bluetooth beacons as well, yeah. So that was one of the key aspects of the project around location. So it was really taking that formalised learning, then having extended lectures and opportunities, and then the informal was really around the new cutting edge. So I know that we had lots of discussions around recommenders for machine learning algorithms. We got into quite a bit of detail around TensorFlow and looking at opportunities there. And again, it was really about building that relationships between Microsoft, the partners, and with the students to really grow what the project opportunities could be, and then really reinforce that learning. So I think that's one of the key things. It's about taking those practical skills of Agile and Scrum methodologies and then really bringing them into real life with Agile Scrum meetings where we could look at source commits, we could look at code, we could look at what the contributions were from each of the team members, and again do that whole peer assessment. So I found it really useful. I think, from our perspective, it was really bringing that real life focus to an academic project, so then you can actually demonstrate some real experiences. So in terms of the project scope, we talked a little bit about the technology we used. So we had a mobile app that was Xamarin and Bluetooth beacons, we had machine learning, so we had some data science aspects there, we had some data cleansing, and then we had all the different clients. So from your perspective, how did you break down all these different aspects between the team members?
Sure, so we were iterating on an inherited code base. And that's key because what we were doing was not building something from scratch, but developing the areas where we felt like we could add the most value.
Yeah.
And we very early identified those as being the consumer mobile application and the recommendation engine, the machine learning.
Okay.
And those go hand in hand because a key part of building a recommendation engine is getting feedback. Getting feedback from the consumers, both explicit and implicit feedback. And so a lot of our focus with the UI of the consumer mobile app was around how can we design an app where giving feedback is a completely natural part of interacting with the app.
Spammed.
Exactly.
So you had to use a consumer app and an enterprise app. So as a local store, I could put my products and services, and as a consumer, I could then say which products I liked, which products I wanted, but not be spammed or feel it was too invasive to your privacy.
So we also developed a number of other components which the system requires to function, but were not the centerpiece of the design. We developed, as you said, the retailer mobile app and the retailer web app, because obviously without that there are no products. We developed database connectors, which we'll go into more detail later. and the client API, which was the glue that held everything
Stitched them all together. Excellent. So, in terms of the technologies, we've already said it earlier on, but Azure was the primary fundamental because it was all cloud services. One of the key things for us, it was about teaching you the whole DevOps lifecycle. So you're very much in source control with continuous integration, deployment. Again, it taught you a lot around the documentation, and we've recently been going through all this to redeploy these services for next year's students, because again, it's about that code reuse, and I really love the way you pointed on that. And that's one of the key learnings that we want to try and get to students, is that when you go into an organisation, yes, you can develop, yes, you can code, but have you ever used somebody else's code? Do you understand code documentation, coding standards? And again, having that ability to be able to build these into these projects is great. So, in terms of these technologies, which one do you think was the most challenging, or one which you hadn't covered on your curriculum?
I'm not sure if any of them were particularly challenging. I think they were all quite usable, but there's one which could easily be forgotten, which is Visual Studio with the ReSharper plugin was fantastic for maintaining coding standards. We have a lot of developers working in the same application, some of whom were actually conversion course students, so they hadn't been programming that long.
And they've been doing Java and things, they were using C# or .NET before, hadn't they?
Using a brand new language, and they hadn't been programming that long. So that tool support, those plugins for Visual Studio were absolutely invaluable for ensuring that some relatively novice programmers were programming at a high level in a well-established style.
Yeah, and you had the documentation standards there as well, So I think what's really great from my perspective about this is both open source technology, so you're running things like DocumentDB, MongoDB, Git, and then you had the Microsoft components, again, across mixed infrastructure. So you had a bit of Linux stuff, you had a bit of Windows stuff, you had Mac in the cloud for doing compiling.
Yes, we did.
I thought it was really cool in terms of that whole technology mix to enable a very small group of students to build and develop a solution that's going to be implemented by a local government as best practice, and then scale that across other regions and areas. So for me, I think the whole technology mix was excellent. So in terms of the actual spot markets, high street areas, what do you think were the primary goals of each of those areas in perspective of the Xamarin app? So where was your focus in terms of that?
Sure. So as I mentioned earlier, we did a lot of work on the recommendation engine and the consumer mobile app. Now, an interesting technology choice we made for the recommendation engine was that we decided to use a document-oriented NoSQL technology.
Okay.
Because what that allowed us to do was iterate on the machine learning very, very quickly. If we wanted to run a new experiment, try some things out, see what was predictive and what wasn't predictive, rather than needing to run database migrations and do considerable refactoring on the development
and
database.
Indexes and
exactly.
Yeah.
We could just make new documents, and if it worked, great. If it didn't, no time lost really. So we moved towards a document-oriented technology. So we used DocumentDB. Now, being students, we had a very limited development budget.
Yeah.
And so DocumentDB turned out to be slightly too expensive for what we had. For production, it's fine, but for the student dev, not so much. So what we did was we also used MongoDB at the same time. So we made a set of database connectors, and we optimized for DocumentDB because DocumentDB is phenomenally fast and powerful.
Mm-hmm. And scalable.
Exactly.
Super scalable, yeah.
Exactly. But to keep development costs down, we did most of our development in in MongoDB.
Yeah.
And that was invaluable in letting us iterate on the recommendation engine. In quite a short time frame, we were actually able to build really quite a predictive engine. So that was a big focus for us over the summer. And as I say, the consumer mobile app, both in terms of the usability, how attractive it needs to be to get people on board, and also the hidden aspects of it, everything
so
under the hood.
Cross-platform support,
Exactly.
Very nice look and feel,
Exactly.
Standardization across all those devices. Again, so it's one build, one deploy, but for multiple. I love the way you picked up on the financial aspects, and this is one of the things that we've really built in from a business KPI aspect to the projects, and what we're doing now is fixing a budget for the team. So again, what we want to try and see is rapid iteration, rapid design, rapid proof of concept. So, you proved that document DB was the right way to go, but it wasn't within your budgets of your project. So again, what we want to try and do is set these projects where the POC which is delivered is fit for purpose for the client, because anybody can build £1 million infrastructure, but not all clients can afford £1 million infrastructure. So if we can constrain the budget, then the client can literally take your implementation and spin that up live after the project, either as a demo implementation or as a proof of concept, or even move that into a live service. So again, by having that whole DevOps lifecycle, they're literally taking your repo, making it into their private repo, publishing that through continuous integration to their live environments, and then allowing their customers to directly access it. And that was a great proving point for us in terms of the whole life cycle of the project. So from concept to implementation with a real case study reference, patterns, practices, and sometimes even GitHub repos that will be made available to other developers in the community. So one of the key things I wanted to focus on now was around the whole agile development and how you worked as a team, because again, this was a mixed team. These are not your general friends. The way the university structures this, it's very random. It picks a team leader, team members, and you literally have to go and build a team. So how big was the Spot Markets team, and what was the diversity of nationality and skill sets?
Sure, okay. So we had 7 people on the team. 4 were from, including myself, were from the Software Systems Engineering program, which is one of the advanced computer science masters, a specialization within computer science. 3 of our students were generalist computer science master students, basically doing a conversion course.
Okay.
So they had comparatively less experience.
But they were good at coding, but not more of the integrations.
Exactly. So the way we split the work was the computer science students focused on a specific area of the project, either on the machine learning or on the consumer mobile app or the retailer web app. And the software engineering students, actually one of the rules of extreme programming is collective ownership, and the software engineering students had collective ownership of the code. I think all 4 of us wrote code in just about every single application.
You were the integrators across
precisely,
all the components. Yeah.
And really at the core of that was Azure. All of our infrastructure was deployed in Azure except for the mobile applications. So that was the glue tying it all together. So all of us being able to work from that single portal made integration and working as a team significantly easier.
Yeah, so in terms of from an Azure perspective, it was very much based on a resource group. So you're all sat within a single subscription with a resource group, with the resources provisioned underneath that. So when you all logged into the portal, you could see what resources and dependencies were there.
Exactly.
And again, be able to understand the complexity of the architecture and the infrastructure. Because I think that's one of the great things that I love about SOA, so service-oriented architecture, is that whole visibility of being able to map out your project and then assign groups, roles and responsibilities to how that infrastructure is then built, but more importantly how it's managed, how it's documented, and what those standards are. So from a high-level architecture perspective, this is your SOA for the high street system. So let's just quickly talk through how this works then.
Sure. So I mean, as you can see, there's a fair few components, some of which we were iterating on what was already there, but a big chunk of which we were actually developing from scratch. And there's a certain amount of complexity inherent in the problem domain. So what we have here is 3 types of users. We have consumers, we have the retailers.
So the person with the shopping trolley is the user.
Exactly.
The shop is a retailer.
And then Kent County Council, or when it's deployed in other regional instances, the local authorities there are overseeing and managing.
So they're the admin.
As a whole, exactly. So there are 2 apps actually which face the retailers. The retailers have a web app and a mobile app. And what the web app is their main interface. But what we wanted to build the mobile app for was specifically as a form of point of sale closure. The consumer app has QR codes. They can present QR codes to the retailers, and the retailers can quickly scan them for a bit of hard point of sale closure.
So like a promotion, or it could be a discount, or
precisely.
But it's an ability to track the user who's used their service and system.
Exactly. Now, related to that was the Bluetooth beacons. The consumers, for privacy reasons, need to opt in and actually switch it on in the mobile application. Can consent to being tracked by Bluetooth beacons, which can be placed in the retailer stores.
So this is like my favourite book is on aisle 3, shelf 2, and there's a promo today.
Exactly.
Right,
So
okay.
there's that info going to the consumer, but also feedback coming to the retailer. So retailers can see footfall in their stores.
Oh yes, 'cause it gives you the flow and the ability to then visualise that flow of traffic.
Exactly. And I think that there is a lot of scope for future iterations to actually continue to build out those analytics.
Yeah. So we actually have a project this year with the next set of students, which is around the location within stores and the promotion of offers within stores. So again, we've took that recommendation on. So that was one of the advices that you gave and the team gave. So we've built a new project just around that area. So again, it's an iteration, a continual feed of ideas and projects.
Exactly. Yeah. So as you can see, right in the center of the diagram, the API, the user API, is basically the glue that holds all the data architecture together. It's the interface for all of the client-facing applications to connect to the database via the database connectors, so that we are effectively technology agnostic. Which is going to make the app more extensible in the future and also helped us to keep development costs down.
Yeah.
Exactly, over the summer. And then finally we have the system software. You can see that on the right hand side, the information retriever and the recommendation engine. They are deployed in the Azure cloud. The users don't interact with them directly. Most of their functionality are scheduled jobs, which
so
run
this is like
every
the
night.
data processing,
Exactly.
data cleansing, and then the machine learning, which then adds the product.
Transforming the data, retraining the algorithms, generating recommendations, and then consumers wake up and they see all of the brand
And
new
that
things.
literally goes out to their social network of choice, whether it's Facebook, Twitter, Pinterest, and provides that authentication mechanism
Yes,
and
yes, it does.
notifications. Superb. So, in terms of the overall data architecture, this is a simple example of how the data architecture is structured. So we've talked about the recommendation engine, the machine learning being the center of everything. And again, it's really about how the data is fed from a single data repository. Some data cleansing has happened on that. Then a machine learning process is run in Machine Learning Studio with some Python code as well. And then that's presented to the desktop infrastructure from both an administration, a retailer and a consumer perspective. So again, very, very simple in terms of how that's architected. And again, as you said earlier, the client API is the key to how that all happens.
Yes.
So from a consumer mobile, you built this all within Xamarin, so this is an example of mobile. So can you just give me a quick example of what this is around? Why did you use Xamarin? We've got a little bunker here. So Xamarin being here, we're doing Xamarin.
Xamarin turned out to be a great technology choice for a few different reasons, actually. Now, the previous Spot Markets team built it in Cordova because in the previous year, Xamarin was still obviously a very immature technology.
And I think it was quite expensive because there was a license fee, and now it's completely
And
free.
now, exactly,
Yep.
exactly. So we were actually able to build it in Xamarin, which was great because we had some significant performance improvements. Cordova doesn't build native applications. It's effectively a wrapper for web technologies on
it's
a
like
phone.
a HTML wrapper, which then is cross-platform, but you have a lot of differences in terms of UI, etc.
Exactly. But with Xamarin, it's actually, you can write your code in C#, and the vast majority of the code, really most of the code is shared across Android and iOS. There's very little platform-specific code.
And you use MVC, so you've got
Exactly.
your model view, yeah.
And so it's really write once, deploy to multiple platforms. The MVVMC architecture was actually one of the Xamarin best practices recommended to us from one of Microsoft's MVPs, from Gary Whittaker.
From Gary, yeah.
Exactly. And it turned out to be great advice because it allowed us to encapsulate the code, to have a clear separation of concerns. So the CS student responsible for the consumer mobile app was focused on certain areas, and the software engineering students did more work with the controllers.
Yeah.
And it allowed us to have multiple different developers working on the same app.
And on the same code base, yeah.
Exactly, without actually stepping on each other's toes. So that is a Xamarin best practice for a good reason.
Superb. So in terms of the recommendation engine, this is probably the most advanced part of the project in terms of machine learning and how this was constructed. So give us a bit of examples about what you did here.
So the key with the recommendation engine is the system needs input, right? And that input comes from the consumer mobile app. So we have both explicit and implicit input. Many actions which the consumer does in the mobile application is feedback. They don't need to say, I am giving feedback now. They give feedback by navigating the application. So for instance, if they swipe right on a recommendation in order to follow it, that's explicit positive feedback. That then goes to the recommendation engine, where we transform the data in a way that's friendly to...
So like customer A likes Harry Potter.
Exactly.
Yeah.
That's then transformed in a way that's friendly to our recommendation algorithms. Now we use two recommendation algorithms. We tried out the Matchbox recommender and the matrix factorization. We tried both of those because there is a lot of empirical evidence that they're very powerful, and they've seen industrial uptake recently. So we wanted to try those out, and you're going to see the results actually in a little bit, and they're pretty good.
Okay.
So yeah, the recommendation engine, you can really conceptualize it as having two steps. There's the profile building, and then there's the recommendation generation. Now, at the most basic level, the profile building is feedback on items, so we can perform collaborative filtering. But actually the Matchbox recommender allowed us to go one step beyond that and do a hybrid recommendation where we could also do content-based recommendation and build consumer profiles and item profiles as well.
So you could say this consumer fits in this consumer group, these are the consumers like this product, this person might also like this product because they're in this consumer group.
Exactly.
So excellent, okay. So in terms of the data gathering, you've got all these consumers out there, you've got all these retailers out there, so talk a little bit about how you got all this real consumer data into your MongoDB and DocumentDB repos.
Sure, okay. So we knew that we had to use real data. Mm-hmm. We're not going to be able to really know if our recommendation engine is effective unless we're testing on real consumer data, real product data, real retailer data. So what we did was we wrote some web scrapers to just download data from various online sources, and then we had real products and real retailers. What we did next was we wrote a web app, basically a survey web app, which presented people who signed up with the data which we had gathered and allowed them to give feedback on that in a way that's similar to how they would actually interact with the consumer mobile application.
So this is where you got the ratings and the interactions. So you had 7,000 interactions.
Exactly.
4,000 ratings of an individual product of 1 star to 5 stars.
Exactly. Which is approximately 80 ratings per consumer.
So you found it, there was quite a bit of interest then if people rated 80 things.
Exactly. But the key thing is actually that is quite a sparse data set. Now, I mean, a fair few people did it and a fair few people produced a lot of ratings, but considering that there were 250 products and only 80 ratings on average per consumer, there's a relative amount of sparsity there. So why don't we see the results?
Yeah, so let's look at the results.
Okay, so this is actually interesting for a number of reasons. First of all, we'll point out that precision is higher than recall.
Yep.
Now this is good. That's a really good sign because precision means that if we recommend something, that means that you probably do like it. So that's the right way around that you want to have it. You don't want
the matrix was very much more accurate in terms of the outcomes.
Moderately so. NMF. It was actually when we did k-fold cross-validation with a set greater than 10, we actually found that the NMF was a little bit less reliable than
so
the Matchbox
that's why
recommender.
the Matchbox recommender is balancing out. So
Exactly.
even though the accuracy is higher, is just slightly less, the recall is a lot higher. So I think that's a great example of how we've used machine learning. Great example of the difference between the different algorithms evaluation.
I'll just make one last point actually. If you see the Matchbox recommender on the left, that's pure collaborative filtering. The hybrid recommenders all outperform the collaborative filtering, and there's a lot of scope to improve content-based recommendation in the future.
So, from us, I think it's thank you. I hope you've enjoyed the quick session there on how we've been doing industrialised projects with UCL and with our ISV community. And we look forward to seeing you for the rest of Tech Days Online. So thank you, Tom.
Thanks very much.
Thank you.